Hi gang! Electricity comes in many forms: AC, DC, electrostatic, lightning, arcs, sparks, and so on. So many that people sometimes don't realize that at the very core, they're all the same thing. So I'll talk about what electricity is, and show how all these forms are just different sides of the same coin. Let's start with the answer to what is electricity. Electricity is a set of phenomena having to do with charge. What's charge? Charge is a property of the particles found in and around atoms. Using the orbital model of atoms, we have protons in the nucleus of the atom and electrons around the nucleus. The protons have a positive charge, and the electrons have a negative charge. If you have the same number of protons as you have electrons, then the number of charges are the same. But if you remove an electron, then the atom has an overall positive charge. Similarly, if we bring in an extra electron, then it has an overall negative charge. In both cases, the number of each type of charge is unbalanced. We say the atom is charged, or has an electric charge. And since that atom is charged, we call it an ion. Things happen when you have an unbalanced charge. Like charges repel each other. So two electrons, both having a negative charge, repel each other. And unlike charges attract each other. So a positively charged atom will attract a negatively charged electron. So once again, the definition of electricity is a set of phenomena having to do with this charge. Let's start with the first of those phenomena, DC electricity. DC stands for direct current, and means that the charges, the charged electrons in this case, are moving in one direction, such as through a wire. The movement is actually fairly chaotic, but overall they move in one direction. Batteries are one way to produce DC electricity. So anything that runs off a battery uses DC electricity. A mobile phone is a common example. When you connect wires to the terminals of each battery, the chemistry inside the battery starts moving ions, or charged atoms, between the battery terminals. At the same time, electrons move in the wires connected to those terminals. The result is DC electricity, with electrons flowing in one direction through the wire. As long as the chemistry in the battery is suitable, this will keep happening. The electrons don't actually move very fast. Think of it as pushing on a row of marbles. The marbles don't go fast, but the effect of the electromagnetic forces are propagated at close to the speed of light, and is felt at the other end seemingly right away. That's why when you turn on a switch, the light turns on seemingly right away. AC electricity stands for alternating current. In that case, the electrons move in one direction, then reverse direction, and then reverse again. They alternate in directions. Anything that you plug into a wall socket in your house uses AC electricity. Though if you're plugging in an adapter, most adapters convert electricity from AC to DC. You can see that if you read the label. The input usually says AC, but for the output, instead of saying DC, it often has this horizontal line with a dashed line under it, which means DC. What generates that AC electricity? There are a number of sources, such as nuclear power plants, hydroelectric plants, and coal-fired plants. But all these basically use some method to run electric generators. Here's an example of one type of electric generator. It has a rotor, which rotates, in this case a ring of magnets, and a stator, which remains stationary, and in this case has coils of wire on it. In the case of hydroelectric power, water turns a turbine, which turns the rotor. As the rotor's magnets pass the wires of the coils, the magnetic field causes electrons to move in the wires. The magnets and coils are arranged such that the interaction will cause the electrons to move back and forth, producing AC electricity.